Hi, I'm James McGuire, and on today's eSpeaks, we're talking about the database market. Specifically, we're focusing on the time series database. We'll talk about some of the issues involved with getting the most out of a time series database. To discuss that, I'm joined by Evan Kaplan, Chief Executive Officer at InfluxData. Evan, very good to have you with us today.
Thanks, James. Thanks for having me. Really appreciate it.
So the time series database is certainly known. It's not as known as some other platforms. Tell us, please, in terms we can understand, what is a time series database and how can it help companies that are focused on cloud and AI, which everyone seems to be these days?
So let me step back to step forward for you.
Sure.
So first of all, in the world that we likely grew up in, there
Yep.
were really only two or three databases that existed, and they were all relational. They were IBM's DB2, Oracle, maybe Informix or Sybase or that sort of stuff that
Big
dominated
names.
the
Yep.
database
Right.
world for a long, long time, and still actually are huge businesses, very, very, very large and profitable businesses.
Right.
What started happening probably, I don't want to put an exact time on it, 15 years ago, is two dynamics started to happen. One is the popularity of open source databases
Right.
became super important. And
The
now it's,
LAMP stack, if you'll remember, the people
yes, of
stuck with
course,
the
the
LAMP
LAMP,
stack. Right.
right,
Yep.
based on MySQL, which was probably
Yes.
the first significant open source database,
Mhm.
relational database that competed with Oracle and ironically is now owned by Oracle, ironically.
Right.
But that trend towards open source has been unstoppable. And I would say it's a very rare new application that's built on Oracle, DB2, or that sort of stuff. Most of the new applications are built on open source foundations. So open source databases are the future. Open source derivative databases have been the future for a long time now.
Well, this
That's
is
the
worth a
first thing.
short tangent. I'm sorry to interrupt. A short tangent of that. Why did open source win that particular war?
I think because if you think about the journey of somebody using a database, one is you want frictionless adoption. So the ability to very quickly download something, play with it, make something useful with it was not something that the normal enterprise businesses had. Wasn't easy. And so that was. Two is because the database is so elemental to whatever application architecture you're building, that ability to see the source, potentially evolve the source, potentially work with it became really important. And then there was just a general trend among infrastructure developers that they didn't want to be beholden to these large, Oracle and IBM contracts,
Mhm.
which were, let's call them officiously executed.
Uh-huh.
Um,
Yes.
and so, basically they didn't want to be trapped. And
Right.
so all those dynamics played. And you saw the adoption of MySQL and Postgres and these other databases, which are now very, very big presences and that sort of stuff.
Right.
So the other dynamic that happened was the breakup from everything being a relational database to being these dedicated databases, these purpose-built databases for specific workloads, which started to make sense the more the cloud stuff started to happen. And so some examples of that, you saw the search databases originally with Splunk and Elastic. You saw the document databases, particularly exemplified by Mongo and the early adoption of that around starting in 2010 or so, or maybe earlier. You saw graph databases. You saw with Neo4j, and now you're seeing vector databases for specific AI and that sort of stuff. But in the interim, there is time series databases started to get really popular.
Hmm.
And so now you can get there probably 10 or 12 different open source time series databases of various market penetration. And there are at least three cloud providers, offering time series, um, um, Azure, AWS, and Google. So it's become a very popular category.
Mhm.
So that's as a preamble to your question. So what are they?
Right.
And so really the way to understand them is that they are the instrumentation layer for every sophisticated system. So they're about measurements. So if you think about it, an easy way to understand it is like sensor analytics on a self-driving car or rocket ship or whatever, or on a home thermostat or things like that, is that it's recording measurements based on time, pressure, volume, light, temperature, what have you. Whatever a sensor does, it speaks time series, right? It speaks what happened at this time and what am I measuring at this time. Mm-hmm. If you think about it, it's so foundational. When you think of how many systems you want to make better, whether it's predictive analytics or that sort of stuff, you want something that's optimized for that. Now, so you asked why you wouldn't use a general purpose database and why this category emerged is because, first of all, general purposes databases aren't built to handle billions of points a second, billions of measurements a second.
Okay.
They aren't built to evict data and summarize data. They aren't built to query at super high speeds. There's just a bunch of stuff they don't do well. And so this category started to emerge, and Paul Dix, our founder, is probably the father of this modern time series databases. We started shipping Influx as an open source project in 2013. Today, daily, there are over 800,000 sites that run it daily around the world. We have about 1,800 commercial customers. So that provides foundation, but there are good products from Amazon, from Azure. There are good products that have emerged in this. So it's a very fast growing category and super exciting. So why is it so okay?
Right.
So then now getting to your real question is, and interrupt me if I'm talking too long.
Well, the one thing one of the tangent I find interesting is that you talk about 1 billion data points where the time series database can crunch that many. I assume that means that it needs a really serious compute power to drive the database, perhaps more than other databases.
100%. Ingest power, a compute to process it, to run the queries, a really effective storage engine to compress the data because you're collecting so much of it,
right.
A summarization engine because you often don't keep high resolution data around for a long time, you summarize it. So a bunch of stuff that would make sense if you said this was my primary data type that I'm working with.
Good. Okay, so that's the great background. So why do companies need a time series database then these days?
So maybe give you some customer examples to sort of ground it. So Tesla's Powerwalls that run all over the world, including at my house where you're charging your car and there's a Powerwall. It's reporting, basically all the measurements that's coming in, how much power is being generated by the solar panels, how much is being collected from the grid. All of that is a series of measurements of change in voltages over time and the measurements. There's a Nest thermostat, right? You're changing the dial every second as a change in measurement, change in temperature, change in reading. So you're instrumenting these things so they become smarter. So that's why it's fundamentally needed, right? Because if you know this is what you're collecting, then you can be really, really good because all your queries can be based on time, all your issues can be based on time, all your information can be, and all your future AI work can be based on that time-based thing. Because if you think about the core of AI, at least as it applies to a lot of these things, it's around some simple, easy to understand is predictive maintenance and self-healing systems and autonomous systems. It's like you want to know what happened, so that you know what's going to happen, right? Gotcha. If you collect enough what happens and you put the system under any pressure or temperature, any pressure or change, then you can see what happens under multiple conditions. Now you've really instrumenting a system. And if you've really instrumented the system, now you can understand how it's going to behave and you can predict how it's going to behave. Now, for a simple system, a cloud service or something like that, you iterate that on a regular basis. Every couple of weeks you update for anomalies and you instrument more and you do all that. But for something like a self-driving car, you do that 1 billion times. You keep correcting, you keep doing that, and you build this massive information. Most of that information is expressed in a time series kind of format. That's when you think about AI, it becomes foundational to have that data pool.
Well, then, am I correct in thinking that the time series database is used more in truly high-tech instances as opposed to a good old-fashioned insurance company that needs to keep track of all their records for car insurance and what person paid and
yes.
What the tech, so it's more for high-tech instances.
It's I wouldn't so it's more for more sophisticated systems. So there are two broad areas. One is the instrumentation of things coming off of sensors, sensor analytics that we talked about, which is things that are reporting things from hardware, but also software is instrumented that way, big parts of the observability work. So financial trading, crypto, things but things that have a fair number of events.
Gotcha.
If you have an event every half hour, okay, that's probably you don't need a time series database. But if you're recording events that are happening across 5 markets every second, you want to think about how you're architecting that data.
Gotcha. Okay. All right. So say there's a company out there that has a time series database or a series of them. What advice do you give them? And what's a typical headache, and how would they solve that particular headache?
That's a great question. Probably the primary headache for time series data is the concept of cardinality. So the way to think about cardinality is how many different measurements over how much different time becomes kind of a multiplicative effect. And so you've got this ever expanding framework of measurements and time. So say I'm reading from a sensor and the sensor is telling me has got 40 different measurements that are coming from it to self-driving car. And I'm recording that every 10 milliseconds, right? Now I've got this tremendous corpus of data.
Right.
And the more cardinality I have, the tougher it is to query that data and the harder it is to work with it. And so a lot of databases fall over with high cardinality. And so a time series database, a good one, handles that high cardinality well. That'd be first thing. Second thing is most data in the time series database should be transformed and evicted over time. By transformed, I mean, so say I'm collecting millisecond data on something. I don't need to, 4 months from now, I don't need to keep all the millisecond data. I may want to summarize it to 1 second data or 10-second data, things like that, to be able to work with it. And that may be perfectly fine for a training data set. And so that summarization has to be sort of built into it, that ability to downsample the data, to shrink it, and importantly, evict data. So databases aren't built to evict data, right?
Right.
Because they're designed to, like the Seinfeld episode, they keep the data, you keep the reservation.
Sure.
But time series data has to be super efficient at the eviction of the data, because very often as you get to some level of scale, your retention policies and your downsampling policies has you evicting as much data as you're taking in. And that has to be happening at the same time. So that's a constraining factor.
Because there are so many data points that literally the system cannot hang on to it all. Otherwise, we just do expand.
Yeah, otherwise you're making it not as performant as it could be. And so you want to be smart. So you have to build something that's capable of evicting data. And then lastly, because you're often keeping around data for long periods of time, that ability to store and compress that data, and because you know that it's time series data, you should be able to do that super efficiently. Mm-hmm. And these are, I can say this we're the market leader by a pretty wide margin in this space. It's a big space.
All right.
But and I'm not just bragging there. I'm just sort of, and we spend a lot of time on that compression and that capability of ingestion and things like that, as our competitors do too.
Well, all right. Speaking of InfluxData, I'll give you a chance to drill down into it. So how is InfluxData in particular serving the time series database needs of its clients? What is the advantage, and why are you ahead of the market?
Well, one is we started earlier.
That's good to know, right? You had first mover advantage.
So two, it's built on the largest open source community out there. And so that's a huge part of it. So a lot of people have either added to it or participating in it and grown. We're now working on our version 3.0. Our 1.0 started out in, probably wasn't released till 2015. So we've cultivated the open source community. We've been liberally licensed. So we really, really have worked hard for that community. So that helps a bunch. Two is, we started earlier. So we're able to win these large enterprise customers, whether it's Salesforce, IBM, Tesla, Honeywell, all that sort of stuff. We've been able to win those OEMs and those contracts pretty early, and so we've been able to build it. And we've continued to invest a lot in product development, a lot.
Gotcha.
So I think those are the things that help us. But I don't want to shake off that we have good competitors. It's not like it, so we have to stay on the top of our game.
Really right. The hyperscalers all offer their own time series.
Yeah. Okay. And we have to take those very seriously because they're the easy button. You're already working in the hyperscaler. All you do is just add.
Right. So, right. It's hard to compete with the hyperscalers for that very reason, because everyone just has the easy button right there.
But having said that, and I know you've covered a fair amount of the infrastructure stuff, there is a really trend. If you look at companies like Elastic, Confluent, Databricks, Mongo, all open source based, who do compete very well with the hyperscalers. And we feel like we do too. But considering you have that large open source community and then you offer it in the cloud, now you've got something that's really a competitive advantage.
Mhm.
Our view.
Well, all right. So let's look to the future, because that's what technology is all about. So the future of the time series database, it's already built for high tech instances. What major developments do you foresee in a couple of years or 2, 3 years ahead?
Well, if we follow the cliches, let's follow the cliches for a little bit.
Please. Yeah.
If as Mark Andreessen had quoted 10 years ago, software is eating the world.
Mhm.
Most of the important instances are in fact high-tech instances, right? Whether it's the building of software to eat the world, or whether it's the sensor where we're constantly sensorifying the real world. And we want to keep building smarter and more autonomous and self-healing systems.
Mhm.
We feel like time series will become a dominant use case. We'll prescribe a huge portion of the data that's collected and the data that's processed, because our whole journey, when you look at the implementation of AI and the benefits of AI, is making smarter systems. When you walk into your house, do your lights go on? Does a thermostat do what you want to do? Does your car drive mostly by itself, if not all by itself? Do we put, I hate to say it, but is warfare driven by things that are driven by AI? Is space travel, like all of the big sort of, I don't want to say people-less, but increasingly AI-driven stuff,
Right.
it wants to be automated, wants to be, autonomous increasingly.
It's interesting about that Andreessen quote about software is eating the world. I'm taking the two literally, and this may be off the topic of time series database, but think about NVIDIA being so wildly popular and really driving things. Of course, NVIDIA sells hardware, actual physical things. I mean, they also sell software, but NVIDIA's claim to fame is really hardware, it's chips. So I have to go back to Mr. Andreessen and go, really, what about NVIDIA? Thoughts on that random thought?
I think so I've been listening to because and actually I've been quite impressed. He's been writing a bunch about AI, and I've been listening to a bunch of podcasts about it. So that's the new theme for him, and he's written a big treatise on it. And I think what he might say, and I can't say what he said, or the might be, is yes, NVIDIA does the chip, but their core competitive advantage is the software tools that drive people to write applications on the chip.
Right.
And so, and clearly we think the chip is incredibly strategic, because you saw, what was it, the Inflation Reduction Act that drove a lot of the new foundries in the US, and the desire to not have dependency on Taiwan for these chips and things like that.
Right.
But I think he'd argue that that's still software mostly.
Mm-hmm. Well, one last thought about time series database as we wrap up. What should people really know about it?
I think what it's most important that developers know, who are architecting systems. And the developers who are working on these advanced systems, and they want to build this pool. One is they want these systems to be autonomous, and they want to be increasingly intelligent, smart, which is essentially the purpose is that the more instrumentation they can collect, right? The more the way I think about it is like a pyramid. The more of the data and instrumentation I can collect at the bottom of the pyramid, the more intelligence I can build at the top. Mm-hmm. Right. And so that ability to collect that, to instrument, to look at it, to build the training model is super important. And the time series, whether it's ours or somebody else's, are really good foundational pieces for that. So I'd have people understand that. Great. I think do mostly, but people are just coming to it all the time.
Sounds good, Evan. That's great expertise. Thank you for sharing your insight today. And I hope you come back and talk with us again sometime.
James, I really enjoyed it. Enjoy the sun over in Oakland.
Thank you.
All right. Thanks.